If you've been playing around with in n8n, which you probably have, then data manipulation is something that you do all the time. You're constantly mapping data from one node to another through expressions. You're constantly linking data from one node to another based on which sort of path that it was going down. And this is the point where you need to start understanding how it actually is happening, how everything actually works, and how you can actually shape the flow of data in your workflows. So, by the way, for context, the name's Muzi. My friends call me MK, and I am the Grand Alchemist of the Guild. If you know what that is, good for you. If you don't know, then maybe it's about time you get to knowing. I am just AI automated systems specialist, and my dream is to help 1,000 people make their first $1,000 online through AI and automation. Um, and today we're going deeper into the lessons that we are taking um, to get that done, to get a real understanding of n8n and how we could actually use it to deliver transformations to other people. So what you need to understand about data manipulation is that it's crucial for delivering clean data. So we already learned about data structures, which is basically the fundamental sort of carrier for information, right? It's lists of items, lists of objects. What we need to understand next is what we understood next is data processing, which is the process of cleaning data. Now we're trying to understand data manipulation or mapping, right? How to pass data between nodes, how to actually start understanding things like that. And this is so that we can actually use that clean data in really interesting ways. So, yeah, data manipulation, if I were to give you a definition, is basically changing, adjusting, or formatting data between nodes. Remember, nodes are just integrations. So, they're just ways to connect together different parts, different services, maybe even like internal services from n8n itself. And yeah, data manipulation is very useful for formatting data so it flows correctly, right? You have to shape data to fit into the next node, basically. Sometimes you do this simply by just dragging. Other times you have to change how it's represented in the expression, and we'll go through that like over time. But that's basically just a good introduction to data manipulation. Let's start with data mapping. So data mapping is something I've spoken about before. It's it's something you've probably done if you've been building workflows, but you just didn't know that it was called data mapping. It's that part where you drag in a key and then you put it in there, and then you see it sort of manifest as these like curly brackets with the dollar sign JSON dot whatever variable that you were trying to map, and you'd be like, oh my god, that's so cool. And when it lights up in green and you're like, oh. But yeah, that is data mapping. Data mapping is basically passing specific data from one node to another using expressions, right? You don't have to drag it in. You could type that, of course, but typing that is kind of, it needs a certain understanding of a bit of JavaScript. That dot notation, right? The dots, it's just a way that JavaScript uses to understand objects itself. So objects, when you're calling keys and values that are stored in keys in objects, you do it through data mapping. You do it through dot notation. So yeah, data mapping is perfect for building with scalability in mind. So understand one thing, and it's the fact that you can build workflows that do things without actually using data mapping. I mean, of course, it's going to be slightly difficult to do useful things, but you can, build really cool workflows by just passing in, like hard coded values that, I mean, the most annoying thing though is the fact that your workflow will do the exact same thing every single time. If you want to pass in dynamic values that change over time, you want to build with scalability in mind, right? So, and to do this, data mapping is very useful. So, um, you want to reference fields are important for the functioning of complex workflows, and to reference these fields, you have to understand the difference between when you're using dot item, dot first, dot last, or dot all, because all of those are very different representations. And again, check the documentation for like deeper versions, because there's all sorts of like data mapping ideas that you really need to sort of understand. But for now, we're just going to be covering .item, .first, .last, and .all. Let me show you what I mean by this. So here I have a simple setup. I'm using data mocking here, something we've spoken about before, just setting up a simple data just so that we can start playing around with it. So we're getting three items here. Let me come into this sort node. Again, the sort node is something we've also spoken about. It can sort items based on some simple methods. Here, we're doing a sort type that is based on code. What we're doing is we're sorting these based on the name, and it's an alphabetical order sort. So here, it's going to sort the names, so the keys or the fields that are named, and it's going to sort these objects based on the name fields inside them. So if we run this, it's going to give us Henry, John, and then Samantha, as you might expect. So um, that was basically simple, right? But where does data mapping kind of go into this example? Well, I have a setup here where I am mapping the sort. Um, I'm mapping the output of the sort sort of I'm mapping the output of the sort node, so the name in the name stored in the sort variable, and I'm also mapping the output of the code node, the name stored in the code node. And let me just run this just to show you. Okay, I'm not going to run this actually. I want you to look at this and tell me what you think is going to happen. So I'm in the schema view right now, and this is useful for like seeing the name of the node that we just came from. So if I'm running things like this, of course I could have sort of um, I could have left it like that, and it would probably turn green anyway. Because what this means, this and the previous sort of way I had it, it means the same thing. It's just an expression for the previous node. So this is just a shortened expression. But if you want the longer one, you can actually reference it based on the name of the node itself. So you can say sort.item.json.name. It's basically the same. And here, what we're doing is we're getting these names. So this would get the name from the item, and then this would also get the name from this item. But again, remember, we nodes run as many times as there are items coming in unless you tell them explicitly not to do that. So here we're not having it execute once, which means it's going to run three times, which means it's going to create three outputs. Um, as long as we understand this, we'll know what's going on. But here is the part that I really need you to pay attention to. You might not have seen .all, you might not understand how it works. .all effectively takes all of them, like all the outputs, and then it lets us reference them by index. So .all one would be item, the second item. And I'm saying the second item because arrays in JavaScript, they start counting from zero. So the first item would be item 0, the second item would be item 1, and the third item would be item 2. Um, if we go into this JSON view, just so that I could show you a list of items or an array of objects. So arrays in JavaScript, this would be item 0, this would be item 1, and this would be item 2. So if we're referencing item 1, we'll always be referencing John Smith, or at least from the code 3, actually, we're referencing Henry Gibson. And now you might understand like what is actually happening here. Here we're referencing a dynamic name that is coming in through the sort. So it could be any one of these names from any of these three. But here we're constantly referencing this middle name from Henry. And now you might understand how it's actually going to represent it in the output. We'll always be grabbing Henry's name for the second name. But for the first name, it'll be whatever name of the item that we're just playing around with at that moment with the node. Really interesting, really cool, but this is just like .all is just one of the many ways that this could be done. You could also do .first here. Let's actually try .first just to show you. So .first is going to pull in the first input, and it's going to pull in the first one always. So for code 3, that was John Smith. So let's check out the output here. It'll always pull out John Smith's name. As you see here, name 2 is always going to be John Smith. And the other ones are changing for name 1. And again, it's going to be similar for dot last. So we can check it out, but as you might expect, it's going to be Semantic Smith. So Samantha Smith, Samantha Smith, Samantha Smith. Everything is working perfectly, and that's basically how they work. Dot first pulls in the first item every single time. Dot last pulls in the last item every single time, and then dot item pulls in whatever item the node is currently working with at that time. Dot all pulls in all of them, but it lets you reference them by index. This is very useful. You'll see why it's useful in the future. We can run certain expressions, like we can run expressions that are evaluating dynamic conditions. Um, and again, this is all in JavaScript. You need a sort of fundamental understanding of JavaScript, but we'll cover this in the future. So like, stay tuned for that. But it's still very interesting. So let's go back and like just keep it moving. So data linking is linking multiple data items across flows. What this means is, say hypothetically you have an if node that is splitting, right? The if node, what it does is it splits the output based on logical conditions. So it evaluates a condition, and then if the condition is true, it splits the flow to the true path. If the condition is false, it splits the flow to the false path. If you have multiple items flowing through, you could be splitting both flows, so both flows could be running forward, which is very interesting to think about. So you can use, yeah, data linking is very useful when you're trying to use it for like during loops, during merging and matching by fields, right? And this allows you to pair data very well. So again, here, when you're doing multiple inputs, you have to be careful. And I will sort of demonstrate this by using a manual trigger. By the way, a manual trigger is just a way to start a workflow so that you don't have to be running every single node manually every single time. Like you don't have to test the step, you can just run the node. I want you to see how they light up. Like it's very interesting. Um, I want you to see how they light up, and then I'm going to show you a different version, and then we're going to see how they light up after that. So we're going to test the workflow. I don't know if you saw that. Let's test it again. Did you see that? It went through the code node as you'd expect, and then it went into the top branch. That's how it does it every single time. It just goes through the branches from top to bottom. But it actually activated, so it activated on this one, and then it went back, and then it activated again, which is very interesting. It was as if we could like sort of disconnect this one and have this be the output here, and then we could even like duplicate it and have it something similar here. Okay, now I want to show you a version that you might find interesting. This is where you merge inputs together. So we want to append whatever objects are coming through, and we want to append with the bottom flow as well. And then I'm going to grab this and just like have it connect in like later on. So like this. Let me have it connect like that. Now I want you to see what's going to happen. This might actually error. No, it will not. Okay. I don't know if you saw that. I'll run it again. I'll run it again. Okay. I don't know if you saw that, but it basically stopped at the merge. So it ran through the top sort, stopped at the merge, ran through the bottom sort, and then merged them, and then went through with all 6 items, which is way more different. So if you understand the difference between what we just did and what could have happened in the future, so like what could have happened in the past if we had let things be the way they are, the workflow would have continued running, like and it would have had to run twice because it would have had to come back and do this bottom flow and then run through every single node that we have afterwards. That's why the merge node is so powerful, and that's why it's always like very interesting to think about these things when when you're designing your workflows. Is actually go through what's going on. So again, this is a simple sort. We're just sorting these things by various conditions. Um, Again, we're doing the exact same thing here. It's a random sort, but we merge these items, and then now we sort of grab the names from them. And it's very like data linking is all just about linking the data properly through flows. So like if you wanted to grab data from sort one, then you could do that. Let's actually try that right now. So we want to do sort one.item.json.name. Um, if we test this step, then you'll get a data linking error, right? So telling you that there's no real connection back to this node sort one, but it's used in the expression. So it wants you to wire up the node, which is very interesting. But when you think about it, there should be a connection because clearly it's very connected over here. So that's like some like data linking is very delicate, but it also like once you crack it, it'll make total sense. If it's turning green here, but we're still getting an error, that probably means that there's something we're not doing according to the way we're linking. So maybe dot item won't work this time. Maybe we want to pull in all of them, but at a certain index, maybe since we want, let's just go index 0 here. And now it actually succeeded. So sometimes when you're linking data, you can't just call dot item because the node doesn't know which item to reference. That's just something to think about. Like always think about these things when you're designing your flows. Okay, so let's talk about pinning data. Pinning data is something I've shown you before. When you sort of have a previous execution that ran and you just want to pin the data so that you can run it again for testing purposes, you can do that, and n8n does it very simply for you. You can also click the pin icon to freeze output at any moment, just so that you can prevent changes. So like anything that happened before does not matter anymore. The only thing that matters is from that point onwards, which is really powerful when you think about it. It's perfect for section testing. Like you could literally detach anything that came before a node and then connect a manual trigger to it and then just run it from that point onwards. And it'll be as if everything happened as if like it will be as if everything was happening naturally anyway. Um, so yeah, again, how to pin data very simply, very easily. You just click on this pin data button. Boom. You could also unpin and then you could edit the data and then save it. It's going to pin again, right? Whenever you save the data that you just edited. So you can unpin that. And yeah, pinning data is very useful for testing. When it comes to editing nodes manually, so when it comes to editing and filtering, um, that's very useful for sort of refining your test data. And filters are also useful for making sure that only the right items pass through. Now again, we did a bit of data processing, so you probably understood like how to use those as filters sometimes. Like you could filter out nodes that just don't have a certain condition um, through those processing nodes, which is like really interesting. So there's a lot of nodes that you could use for a lot of different cases, and all of these different logical ways that you could like integrate nodes together is just how it's just like the beauty of like how your creativity also goes in like along with your technical mindset. Let me just let me run through something here. This is something along the lines of data linking when you're working with loops. So here we have a system whereby we pin some data here because we wanted to like show something, but you'll understand what's going on in the future. Let me just run this right now. Loops are very interesting and they're very powerful, and we're going to run through how they work at a future time. Let's go into this edit fields node where just to see what's going on. If you've been following along, then you understand that this JSON.name is just going to pull in the name of the item that we're dealing with right now. Loops are very good at splitting um, incoming items. So if there were three items coming in, no, I mean like the list of items had three of them inside there, only one item would be flowing in at a time. And then this is just going to pull in this name, and then this is actually referencing a node from outside the loop, which is always very interesting. So we were doing the exact same kind of operations. We were pulling in the first one, the last one, and you might be wondering what this all is. Let me explain it to you in probably the simplest way. Okay, so you might recognize .all here, that we're pulling in all of the items, meaning that it's the array, it's the list of items in there. So there were three items in there. We're pulling all of them. Now, the square brackets would have delineated the index, but what we're doing here is we are calculating the index programmatically. So math.floor is a function in the math library that is used to sort of round down whatever is inside its brackets. Let's see what's inside the brackets. So here, the dollar sign, whatever, we're trying to reference a variable inside here. And what it's referencing now is this code for, meaning that it's the actual node that we're referencing in the first place anyway. And we're referencing .all again, meaning that we're referencing that same list, that same array. But what we're doing here is we're getting the length of the array. So array.length is an actual, it's an actual inborn variable in the data type of arrays. And when you do so any array.length, you get the number of elements in the array. So not the highest element. Remember, since our list has three items in it, we're going to get a length of three, not two, because two is the highest index for any elements in there, since arrays start counting from zero. So it's 0, 1, 2, but there are three items in there. So we're going to get three. Now let's calculate what's actually happening here. This is going to return 3. 3 divided by 2 is 1.5, but we're rounding down with math.floor, so that's going to be 1. And then all at index 1 is going to give us the middle item that is being outputted by the code node. And that's why we're getting Henry Gibson, and that's why we're getting Henry Gibson here for the middle name. So yeah, imagine having a ton of items and you just don't know which is the middle one. That's just basically the simplest way you could do it programmatically. Just calculate the length of the array that's incoming, and then just actually link the proper item, and then extract that data, which is like really powerful. Okay, so real world applications for this are like way too many to count, but a few of them include automating lead scoring by mapping data. This is something I showed you before, and it's very useful for like many businesses who like they don't really have time to like just be doing lead scoring all by themselves through people, because all their people are just being used for sales calls and so on and so forth. Um, if they could have like automated methods for doing scoring, so that they know which leads to actually follow up on and which ones to let go because they're just not qualified anymore, then this could be handled by a whole system, which is like very very useful. So there's another application where it's like filtering incomplete leads to save resources, and again this can be done automatically, right? If your lead score is way too low, you can just literally delete them from the database if they're just not responding anymore. If you have a database of people who have been buying from your e-commerce site, and you have that one person who is You know, like they filled in, but they had an abandoned cart, and you've been contacting them, telling them about their abandoned cart, but they just don't really care. Um, you could just filter them out. You know, just like since their score is way too low, you can just not consider them when you're trying to send emails in the future time. So yeah, you can merge historical information to have complete data. And again, this is all just about like the flows. When you have different flows running, you can merge all that data, and then do really interesting stuff in the future. So yeah, pushing high value leads to sales. Again, like all of this is possible. All of this and more is possible, which is like really really powerful. Let me show you something really cool. So here you can do data linking when working with the God node. If you don't know what the God node is, it's my favorite node. Um, again, we'll run this first, and then I just want to show you what's going on here. So we still have those same three items, right? The same list of three items, but now the God node has this really cool way of data mapping. Let me show you. So when you drag in a piece of data, it's just gonna say this. It's just gonna be like JSON.name. You might be wondering why it looks different here. This is the same name. Like don't even get it twisted. This is the same name. Um, it is the same name, but here it's just being delineated by the input variable. Um, this is not only much more robust, but it's also more useful. Like because you could rename this by referencing the actual sort of the name of the variable itself, and this should be fine as well. Um, so it's called code5.item.json .name. Okay, so what we wanted to do here was to get the first name as name1, right? That was just a simple application of whatever we were doing. And you might recognize this as yeah, something you could do with the set node as well, but it's just like it's very simple to do with a code node as well. Something interesting to understand is that this is running once for all items. This is running once for each item. If we wanted to run once for all items and then try it, it's going to give us an error for .item here. And .item is only available for one run once for each item. What we need to do here is to actually reference the actual item that we want. So we have to say we want the first item or we want the last item and so on and so forth. And it's only going to give us that exact item that we want because it's only running once for all the items. So yeah, very cool stuff. Um, let's just wrap up. So you've leveled up and you've unlocked mapping data between nodes with expressions. You've leveled up how uh, you link data items across flows, just so that you don't get like data linking errors. You now can pin and edit output data for confident testing, which is something you should be doing often. Like if you're not mocking data through your set nodes and your code nodes, you should just be pinning data like as much as you possibly can. Also, editing your output data and then just like having that get pinned so that you could use it is very useful as well. So, and you also know how to filter inputs for focused workflows, which is like really, really useful and really, really powerful. And again, as I said before, there are many ways of filtering. There's even like a dedicated filter node, which we'll explore at a future time. But yeah, you now understand all these things, and all these things are going to be very useful. I'm sure you're ready to dive deeper. I know I am. And next time we're going to be looking at data types and the representation in n8n. You're going to be diving into strings, numbers, and everything in between. I hope to see you there, Alchemist. So I'll see you soon.